Laplace transform the Laplace transform of x of t is x of s is equal to minus infinity integration over minus infinity to infinity x of t into e raised to power minus st into dt, and therefore the inverse Laplace transform and inverse Laplace transform of x of s is x of t is equal to 1 over 2 pi j integration over sigma minus j infinity sigma plus j infinity x of s into e raised to power st into ds, and the relationship is x of t is equal to x of s. Next is the convergence. So the Laplace transform is a Fourier transform of, we know the Laplace transform is the Fourier transform of x of t into e raised to power minus sigma t, and hence a necessary condition for convergence of the Laplace transform is the absolute integrability of x of t into e raised to power minus sigma t. Hence the condition is that integration over minus infinity to infinity x of t into e raised to power minus sigma t, this is absolute integrability, into t is less than infinity. So the range of sigma for which the Laplace transform converges is termed the region of convergence. Next is the S plane. So it is convenient to represent a complex frequency S graphically in terms of the complex plane, and that is termed as the S plane. So S plane is shown like this. This is the S plane. Complex frequency S is equal to sigma plus j omega. So horizontal axis is the real part, that is sigma. Vertical axis is the imaginary part, that is j omega. So we can have the poles and zeros on this S plane. So the zeros are supposed at s is equal to -1. Another zero is at -4. So this is a -4 plus j2, and this is -4 minus j2. So these are the not poles. This is a 0. Zeros are represented by the small circle, and the poles are here at s is equal to 4. This pole is here. Another pole is at this is 2. So this is, and this is a 3. This is -3. So another pole is here. So the poles are represented by the cross and the zeros are represented by the small zeros. So here this is a representation of the poles and zeros on the S plane. So how many zeros are there? 1, 2, 3. 3 zeros are there, and 1, 2, 3. 3 poles are there. So this is the S plane. This is the S plane. So let us find the Laplace transform of the function x of t is equal to e raised to power 2 by 3 t into u of t, and find ROC and the location of the poles and zeros in S plane, and determine Laplace transform, and also find ROC and the locations of poles and zeros in the S plane. So this function is given to you, and the solution is, so x of s is equal to Laplace transform is equal to minus infinity to infinity x of t into e raised to power minus st into dt. Now we have to put this x of t is given. X of t is e raised to power 2 by 3t. Therefore, minus infinity to infinity x of t is e raised to power 2 by 3t into u of t into e raised to power minus st into dt. So this is the unilateral function, and therefore we have to change the limit from 0 to infinity. That is e raised to power 2 by 3 t, u of t is 1, and therefore e raised to power minus st into dt. And this we can also write from 0 to infinity e raised to power minus s minus 2 by 3 t into dt. So integration of this is minus 1 over s minus 2 by 3 e raised to power minus s minus 2 by 3 t, and to put the limit from 0 to infinity, and we can find here this part goes to 0 as t approaches infinity. This part will go to the 0 as t approaches to infinity, and therefore minus 1 over s minus 2 by 3, 0 minus 1, so we'll get 1 over s minus 2 by 3, and the real part of s, this real part of s is must be greater than 2 by 3. Real part of s must be greater than 2 by 3. As we can write, s minus 2 by 3 must be greater than 0. So s must be greater than 2 by 3. And this is the real part of s must be greater than 2 by 3. And therefore, the Laplace transform does not exist for the sigma. This is the real part, because you know the complex frequency sigma is equal to so S is equal to sigma plus j omega. So this real part of S is nothing but this sigma. So this sigma must be greater than 2 by 3. And this Laplace transform does not exist for sigma if the sigma is less than or equal to 2 by 3. Laplace transform does not exist for sigma is less than or equal to 2 by 3, since the integral does not converge. Since the integral does not converge. And ROC for this signal is sigma is greater than 2 by 3, and therefore we have to show on the S plane. So on the S plane we can show this is sigma j omega 0, and this is a 2 by 3. And sigma should be greater than, what is the ROC? ROC is the sigma should be greater than 2 by 3. So this is your ROC. This is called ROC for sigma is greater than 2 by 3. So this is one pole. Because of Laplace transform, we have got Laplace transform is equal to x of s is equal to 1 over s minus 2 by 3. So this is the zeros and this is the poles. So pole at s is equal to 2 by 3. So this is a 2 by 3. And there is no zeros, only one pole is there, and pole is at s is equal to 2 by 3. And this is the region of convergence. So this is the location of the poles and zeros. As there is no zero, only one pole is there at s is equal to 2 by 3. So this is the answer for this.